Okay, so your review problems had to do with long division. And judging by a couple of questions, you knew that they were missing an x, so we had to put something in there for a placeholder. That is 0x. So I'm going to go ahead. How many times will x go into x to the third?
X squared.
X squared times. When I multiply those, I get x to the third. And then negative 3 times x squared gives me negative 3x squared. Subtract or do the inverse. So put a minus in front of that x to the third and then change that negative into a plus there. And subtract. And then bring down the. How many times will x go into x squared? X times. X times x is x squared. X times negative 3 is negative 3x. Again, do the inverse. Say again.
Would it be negative 3x?
Should be positive because it was a negative, and when I change it, when I subtract, then I will have an inverse, and so it'd be a plus.
Okay.
How many times will x go into 3x?
3.
Should be 3. 3 times x is 3x. And 3 times negative 3 is minus 9. So how many times will it go in? It will go in x squared plus x plus 3. Next one starts out with a challenge because I've got to put that in order from least to greatest. I should raise that up since I am. Okay. X to the fourth, x to the third, x squared, x. So I have all of those in descending order. So how many times will 3x go into 6x squared?
2x to the third.
All right, 2x to the third.
How many times was what?
She said
3x go into 6x to the fourth.
wrong.
All right, so 3 times 2 is 6. X to the third times x first is x to the fourth. Then take 2x to the third times 1. Do the inverse. That gives me 0 here and negative 3x to the third here. Okay. How many times will 3x go into 3x to the third? 1x squared, right? So negative 1x squared is a negative 3x to the third minus x squared. Okay, when I am going to get the inverse, I'm going to subtract both of those. When I subtract this, then it becomes plus and plus. Okay, with this 9x, 3x will go into 9x. Actually, this should be a 0. No. So 3x will go into 9x 3 times. Bring that down because I should put the 0. This is going to be 0 here. Okay, so minus 6 over 3x plus 1. Is my answer. Leave that for a sec. Hunter, you probably ought to watch the long division 1, chapter 3, section 3. Okay?
On Larson,
Yeah.
watch, chapter 3, section 1,
Section 3,
section.
it's the very first exercise. It's on long division. Okay, for synthetic division, there is an easier way to do this if I'm able. For instance, with this one right here, I am able to do synthetic division. That one I am not because it does have a coefficient. So on this one, if I go and I put the coefficients into the box, 1, -2, 0, 9, and I synthetically divide by the opposite or the inverse of -3, which is +3, then I will get that answer pretty quickly. Let's watch that. I am going to shut that light off closest to the root. Oh, shoot.
Put down, here's how it works. Now, we're dividing by x minus 3, so we put down 3. And then set it up like this. Now we want to write the coefficients and the constant up here. And we just want to make sure that we have an item for every degree in the polynomial numerator. So let's see, we start out with a fourth degree term, and it's 2. So we need a fourth degree, third degree, second degree, first degree, and then a constant item. So we're kind of on the lookout for that. So now let's see, this is our fourth degree coefficient. Our third degree coefficient is -3. Our second degree coefficient is -8. Our first degree coefficient, oh, there's no first degree term, so we need a 0 as a placeholder, and then our constant is -2. And then we can roll through this synthetic division very quickly. The 2 just comes down and we multiply, add, multiply, add, multiply, add. 3 times 2, 6. 6 with -3, that's 3. 3 times 3, 9. 9 minus 8, 1. 3 times 1, 3. Add, we get 3. 3 times 3, 9. 9 minus 2, 7. The 7 is the remainder. Now we just write our answer. The polynomial part is here. These are the coefficients, and that's the constant involved in this polynomial. And the polynomial is 1 degree smaller than the one we divided into. We divided into a fourth degree polynomial, so we start out with 2x cubed, and then plus 3x squared, and then plus 1x, and then plus 3. And now the remainder is 7, and if we're going to write a complete answer here, it would be plus 7 over the divisor. Now we're dividing synthetically by 3, but the true divisor was x minus 3. So it's 7 over x minus 3. And here's our complete answer.
All right, so can you rewind that? Let's do this one. I have 3, I've got a 1, a -2, a 0, and a -9. The first thing I do is I bring down the very first number here. So 1. Then I multiply and add, multiply and add, multiply and add until I'm completely done. Okay? So 1, 3 times 1 is 3. Add these two. -2 plus 1 plus 3 is 1. Multiply these two. 3 times 1 is 3. Add these two. 0 plus 3 is 3. Multiply these two. 9. And -9 plus 9 gives me 0. 1 degree less, I started with x to the third, so this is going to be x squared plus 1x plus 3. Notice how that is exactly the same as what I got last time. Okay, bring down the first coefficient, multiply, add, multiply, add, multiply, add, multiply, add till you're finished. Now I'm going to talk about remainder theorem and the importance between that, and I know we watched that last semester as well.
So a rather speedy way to go through the problem. Now, there's another situation involving the synthetic division process. There's another, I want to say, it's the same technique, but it's used for a different purpose. There's another purpose for which this synthetic division is used. Suppose we think now about this polynomial. Now I'm just going to come out here to the left, and I want to write it as a function. I want to say that that's f of x. And let me show you something. So I'm going to write f of x is this polynomial numerator, 2x to the fourth minus 3x cubed minus 8x squared minus 2. Now, let's suppose I want to evaluate f of 3. Now, to do that, I would need to say, well, this says, in the f function, replace x with 3 and evaluate. I would have 2 times 3 to the fourth power minus 3 times 3 cubed minus 8 times 3 squared minus 2. Now, 3 to the fourth power, big number. 2 times that big number, even bigger. 3 cubed, that's 27. 3 times 27, pretty big number. 8 times 9, that's 72. We're dealing with fairly large numbers here. Now, it turns out, though, that after the smoke clears on all of this, f of 3 turns out to be 7. Why do I know that? Well, I know that because I know that evaluating a polynomial for a certain value like this can be done by using synthetic division. And if we took this polynomial and divided synthetically by this value 3, I'm not talking about negative 3, I'm talking about 3. Divide synthetically by 3, then the remainder will be the function evaluated for x being 3. That is, this 7 corresponds with the remainder in our synthetic division process. And then that then gives greater power to the whole synthetic division idea. We can evaluate f of just about anything we want to very conveniently without using such great big numbers that we would find using this replacement idea. So it becomes a more powerful tool because of that technique. That idea is called the remainder theorem. The remainder theorem.
Okay, so remainder theorem. Try the first two up there with synthetic division, please. X to the fourth plus, minus 10x squared plus 4 and then the next one as well. Okay, bring down the first one. Now multiply, add, multiply. So multiply these two, negative 3. Add these two, negative 3. Multiply these two, negative 3 times negative 3 gives me a positive 9. Add these two, negative 10 plus 9 gives me a negative 1. Multiply these two, gives me a positive 3. Add these two, positive 3. Multiply these two, negative 9. Add these two, negative 5. Starting with one place,
Wouldn't that be a negative 3 after your 9? Because a negative
Nope.
1,
negative 1 times a negative 3 gives
that's a
me,
plus 3, x plus 3.
no, it is not.
You did
Synthetically, you divide by the inverse.
Yeah, invert the 3. Why can't you do this if it has a coefficient?
Doesn't work,
You won't even get a close answer?
no.
No.
So one less is x to the third minus 3x squared minus 1x plus 3 minus 5 over x plus 3.
So could you minus, oh, I have that, I just wrote it weird. much easier than long division.
Because I gave you a shortcut?
This is so much easier.
Yeah, it is. So bring down the 5. 5 times 2, negative 10. Add those two, negative 2. Add those, 4. Add these, 3. Multiply those, negative 6. Gives me 0 there. So 1 less, it started out with a third, so x squared minus 2x plus 3. Now, that being said, the remainder theorem then is exactly the same thing using synthetic division. So this is my inside the box area. And this is going to be my divisor, okay? I don't change this even to do synthetic division, okay? So negative 1 I have 4x to the third, 10x squared minus 3 minus 8, all right? Move down, 4 times negative 1, negative 4, add those, 6, negative 6, negative 9, positive 9, 1. 1 is going to be the answer there. So I'm just going to check that real quick. 4 times 1 to the third power, I'm sorry, negative 1 to the third power, plus 10 times negative 1 squared, minus 3 times negative 1, minus 8. This is going to be a negative 4, plus 10, plus 3, minus 8. 6 plus 3 minus 8, 9 minus 8. Oh, look like it's right.
So when it's the f of x, you don't divide, or you don't do that.
You don't change the inverse. You don't divide by the inverse, I should say.
So you, for negative 1, you do 4x squared plus 6x minus 9 plus 1 over what?
X minus 1, but that's not what you're doing that for. You're trying to find out what is your answer for a function of negative 1.
Oh,
Your answer is 1.
Oh, so it's
Using
like
remainder
plugging it in.
theorem.
Okay, so your point would be negative 1, 1.
Negative
1, 1.
Yes, yep, you're correct. So that's how you use remainder theorem. Finding a point on a grid.
You want us to do the estimate?
No. Look at page 200. Talk about factorization. Factorization using remainder theorem or such. With this one, I could factor it. That would be my factoring there. Set both of them equal to 0.
How did you factor? Oh, you did the,
Yep,
what you would call it right on. I can just plug the quadratic formula.
you can.
So how do I, if it gives me like a third, for x to the third power, how would I use the quadratic formula? How would I take one more x power out of it?
Say again.
It's like on the one to your left. If it gave me that, x cubed minus 3x squared minus x plus 3, how would I use the quadratic formula on something like that?
This?
Yeah, how would I take one more x value out of that to get it to x squared?
Oh, it's not gonna ask you to do that.
So it's not gonna ask us to factor that?
No.
Okay.
That's why I specifically went to that one there.
Good.
Sometimes you will have a repeated one, like x minus 2, and it'll be x minus 2 times x minus 2. Or you may have to repeat the division of it.
In this problem, we will show that x plus 3 is a factor of f of x equals x cubed minus 19x minus 30. Then, we will find the remaining factors of f of x. To solve this problem algebraically, use synthetic division and set it up as shown below. You can begin by bringing down the 1. 1 times negative 3 gives you negative 3, and 0 plus negative 3 gives you negative 3. When you multiply negative 3 by negative 3, you get positive 9, and negative 19 plus positive 9 gives you negative 10. When you multiply negative 10 by negative 3, you get positive 30, and when you add negative 30 and positive 30, you get 0. Therefore, your remainder is 0. Because r equals 0, f of negative 3 also equals 0. And the quantity x plus 3 is a factor. As you can see from this synthetic...
Okay, so if I use synthetic division and I get the answer of 0, then whatever I just used, for this instance, negative 3, that becomes then a factor of that particular equation. Now, I can use this 1x squared minus 3x minus 10 and divide it by negative 3 then.
division. Your resulting quadratic expression is x squared minus 3x.
Actually, I can factor
minus
that.
10. This factors as x plus 2 times x minus 5. Therefore, the complete factorization of f of x is x plus 3 times x plus 2 times x minus 5.
Notice that I have a quadratic here where I can use my quadratic formula, or I can go ahead and use trial and error to get this factor. Do not forget when you answer it that you are to put that one in as well, okay? So that is important. So those three are my factors of that equation.
Section 3.
4. Yeah, 3. Just finishing up section 3.
There's 5 sections in it?
Yeah. Zeros, the polynomial is over on 201. Factor the polynomial and then set it equal to 0. Wherever x is 0, then that's where x is going to cross over the line. Rational zero test, and that's when we're drawing the line to find out where it crosses exactly on the x-axis. Rational zero test, look at the constant term and find the factors of it. Then see if those give you a 0, if you replace it with x. Example 2 on page 202. So possible zeros, I have x to the third plus x plus 1. Oh, wow. Positive 1 or negative 1 has to be my factors there because of the plus 1. So I check to see if either one of those work.
Or factors of the constant term.
Constant term is the last number
Okay.
that doesn't have any variable on it.
Factors meaning two numbers multiplied together. I forgot what factors multiple were.
Factors are two numbers that multiply together to make one other number.
Multiple.
Multiple is when I take that number and multiply it, that gives me a multiple. Like if my
6
number is
times
4, 4 times 2, 8 is my multiple of 4.
It is multiple of 4 and 2.
Yes.
Okay. I see what you're saying.
Okay. So,
So if the constant was like 4, the possible list of they're not necessarily rational zeros, but the list of possible ones would be the -1, +1, -2, +2, and -4, and +4.
correct.
You just have to try all those out.
Absolutely. Trial and error.
Okay. That's simple enough. And you can plug those in with the synthetic division, right?
Yes.
And if you get 0,
If you get 0, that's your answer. That's one of your answer, one of your factors.
it's pretty slick.
Absolutely. So let's watch one, and then I'm going to have you do a couple.
Find the rational zeros of the function. Part A, f of x equals x cubed minus 5x squared plus 2x plus 8. Because the leading coefficient is 1, the possible rational zeros are the factors of the constant term. Therefore, your possible rational zeros are positive or negative 1, positive or negative 2, positive or negative 4, and positive or negative 8. Now you need to
Which
test
are
these zeros.
factors of 8.
First, test negative 1 by substituting negative 1 for x and f of x to get f of negative 1 equals negative 1 cubed minus 5 times negative 1 squared plus 2 times negative 1 plus 8, which equals 0. Because f of negative 1 equals 0, you know that negative 1 is a 0 of f. Now test 1 by substituting 1 for x and f of x to get f of 1 equals 1 cubed minus 5 times 1 squared plus 2 times 1 plus 8, which equals 6. Because f of 1 does not equal 0, you know that 1 is not a 0 of f. Now test negative 2 by substituting negative 2 in for x and f to get
Now
f
there,
of
he,
negative 2
she,
equals negative 2 cubed minus 5 times negative 2 squared.
She just plugged
they're
it back
substituting it in.
2 plus 8, which equals
Which
negative
might be
24.
just as easy.
Because f of
Might be.
negative 2 does not equal 0, you know that negative 2 is not a 0 of f. Now check 2 by substituting 2 in for x and f to get f of 2 equals 2 cubed minus 5 times 2 squared plus 2 times 2 plus 8, which equals 0. Because f of 2 equals 0, you know that 2 is a 0 of f. Next, test negative 4 by substituting negative 4 for x and f to get f of negative 4 equals negative 4 cubed minus 5 times negative 4 squared plus 2 times negative 4 plus 8, which equals negative 144. Because f of negative 4 does not equal 0, you know that negative 4 is not a 0 of f.
I think when
Now
it
test
starts getting
f
bigger,
of 4
it's
by
probably easier to do
substituting 4
synthetic
in for
division.
x and f to
Yeah,
get
where it
f
starts
of
getting
4
bigger
equals
values,
4
use
cubed
Yeah.
minus 5 times 4 squared plus 2 times 4 plus 8, which equals 0. Because f of 4 equals 0, you know that 4 is a 0 of f. Now test f of negative 8 by substituting negative 8 in for x and f to get f of negative 8 equals negative 8 equals negative 840. Because f of negative 8 does not equal 0, you know that negative 8 is not a 0 of f. And last, test 8. By substituting 8 for x in f, you get f of 8 equals 8 cubed minus 5 times 8 squared plus 2 times 8 plus 8, which equals 216. And because f of 8 does not equal 0, you know that 8 is not a 0 of f. And you can conclude that the polynomial function f of x equals x cubed minus 5x squared plus 2x plus 8 has 3 rational zeros, which are x equals negative 1, x equals 2, and x equals 4.
How does she not stutter?
How does she what?
Not stutter?
I don't know.
She's a,
That was negative 1.
Could you put the pause at the very end of it? I was trying to write it.
Yeah, I was just trying to write the answer part of that.
Find the rational zeros of the function, where x equals negative 1, x equals 2, and x equals 4.
Okay.
oh God. Factors of 40. 140, 220, 410.
Okay, how about the next two?
That's a lot.
There's nothing times 6 that can get you 40. No, there isn't.
Where are you getting 40?
I'm doing a problem, the homework just.
Oh.
That's to give you negative 2?
No, I need, what times 6 will equal 40? Nothing.
What times 6 will make 40?
Yeah, x times 6 would make 40. No whole number, right? I don't know why I can't do that, my brain's not working. Has to equal 0. So on this one, it's asking me find the remaining factors of f of x. And I gave them 2 of them already. Now I'm just using, even if it's like x to the 5th power, as long as the first leading coefficient is 1, that rule still applies. If the leading coefficient is not 1, the rule doesn't work.
Correct.
Oh boy. So how do you go about it then?
There's some other things. There's a Descartes rule of signs that you can do.
Would you just take, like if the leading coefficient was 6, all your factors would just be like x plus 3 all over 6?
Yes. If you look over here on example 10 on 209, that does exactly what you're just talking about. See where the leading coefficient is 6?
Mm-hmm. They just divide it
So
by
your
6.
coefficient of 2, your factors of 2 are on top, which is your constant. Factors of 6 are on bottom, which is your leading coefficient.
Wow. That's kind of written really complicated.
Yeah.
I don't understand that, but I'll give it a shot.
I know, looking at number 2, that it's got to be 1, negative 1, 2 or negative 2, 4 or negative 4. And I know, looking at number 3, it's got to be 1 or negative 1, 2 or negative 2, 3 or negative 3, or 6 or negative 6. I know it's got to be those. Those are the ones you should be looking at to plug into there. To find where you're going to cross the x-axis at.
You plug those in, your x's are where you cross the x,
Yes.
that's where your parabola or your, no, that's not a parabola.
If you look on 207, it shows you a picture of where it's touching the x-axis.
Oh, yeah, on the 3.19.
Mm-hmm.
When you're using the synthetic, you keep the original number, you don't invert the sign, right?
When you're using a function, you keep the original number.
Okay.
Okay, so gonna do the second one.
Find the rational zeros of the function. Part B. F of x equals x cubed plus 2x squared plus 6x minus 4. Because the leading coefficient is 1, the possible rational zeros are the factors of the constant term. Therefore, your possible rational zeros are positive or negative 1, positive or negative 2, and positive or negative 4. Now you need to test these zeros. First, test negative 1 by substituting negative 1 for x in f to get f of negative 1 equals negative 1 cubed plus 2 times negative 1 squared plus 6 times negative 1 minus 4, which equals negative 9. Because f of negative 1 does not equal 0, you know that negative 1 is not a zero of f. Now test 1 by substituting 1 for x in f to get f of 1 equals 1 cubed plus 2 times 1 squared plus 6 times 1 minus 4, which equals 5. Because f of 1 does not equal 0, you know that 1 is not a zero of f. Now test negative 2 by substituting negative 2 in for x in f to get f of negative 2 equals negative 2 cubed plus 2 times negative 2 squared plus 6 times negative 2 minus 4, which equals negative 16. Because f of negative 2 does not equal 0, you know that negative 2 is not a zero of f. Now check f of 2 by substituting 2 in for x in f to get f of 2 equals 2 cubed plus 2 times 2 squared plus 6 times 2 minus 4, which equals 24. Because f of 2 does not equal 0, you know that 2 is not a zero of f. Now test f of negative 4 by substituting negative 4 in for x in f to get f of negative 4 equals negative 4 cubed plus 2 times negative 4 squared plus 6 times negative 4 minus 4, which equals negative 60. Because f of negative 4 does not equal 0, you know that negative 4 is not a zero of f. Back to test 4 by substituting 4 in for x in f to get f of 4 equals 4 cubed plus 2 times 4 squared plus 6 times 4 minus 4, which equals 116. Because f of 4 does not equal 0, you know that 4 is not a 0 of f. And you can conclude that the polynomial function f of x equals x cubed plus 2x squared plus 6x minus 4 has no rational zeros.
Which means it's not going to touch the x-axis at all. I know I gave you another one, but we're going to go ahead. Leading coefficient is 1 versus leading coefficient is not 1. That is over on page... God, I was just talking about it.
209.
Let me go a little bit further. 209.
Yeah.
203 and 204 as well. Does the same thing. Factors of 3, which is the constant, over factors of 2, which is the leading coefficient. So factors of 3, you'd have 1 plus positive, negative 1, positive and negative 3, positive, negative 1/2, 1 over 2, and positive or negative 3/2, 3 over 2. Okay. Let's talk about direct and indirect variation. That is over in 3.5 on 213. Directly, if it directly varies x and y, then it's going to be side by side. Equation y equals kx. K is my constant. So directly means right by side. Indirectly means divided by. We're actually multiplying the direct and dividing the indirect.
What page is this on?
213. Inverse, combined variation and joint variation. Combined is where we're taking more than 2 variables. In this particular example 6, you have volume, you have pressure, you have temperature that's in Kelvin. So you are actually doing more than one thing here. You are, 2 variables are varying inversely, which is dividing them. The Kelvin temperature divided by pressure. And then you also have it varying directly with volume because it's side by side.
So F varies directly as R squared and inversely as G. What the hell does that mean?
Say again?
F varies directly as R squared and inversely as G.
F varies
Directly as R squared.
So F equals R squared over G.
So it varies directly is another word.
Side by side.
Divide
No, they're side by side.
or multiply.
Yeah. But one's going to be on one side of the equals and one's going to be on the other.
And then inversely means
Inversely means you're dividing.
so F times R squared over G.
F equals R squared over G. Because when you're doing direct, look over on example 4.
On 213.
Yeah, 214. If it is directly, it is one equals the other. Or even at the top, it says the area A is directly proportional to the square. So directly proportional means A equals the square of something.
Is this homework due before spring break?
I'll probably put it at the end of spring break.
You would be the best.
I am.
You'd be the goat math teacher.
Joint variation means that they are putting them together. There's more than one variable in this one as well. So they're combining them, but we don't want them to be combined. They are joining them together. So interest equals the principal times the time. Times K, whatever it is. K is the constant, evidently.
So is the homework due the 15th then?
Probably, yes.
When does spring break start?
Next week?
Start
Yep.
Friday.
Oh, boy.
Next, yep, well, next Monday.
No, that Sunday would be the 17th, not the 15th. The 15th
I'm
is
going to
Friday.
Cancun. I'm going to be all girls gone wild.
I'm gonna be at work.
I'm going to Corpus Christi. I hope I don't see any girls gone wild, because that one right there, he would love that.
I have a coworker who's going to California, and I was like, Lisa, it's not there.
You go to Corpus Christi.
I am. I'm going to San Antonio on Wednesday. And so when I'm finished with my conference in San Antonio, we're going to drive over to Corpus Christi because it's only 2 hours.
You get blackout raged.
Huh? No.
You're not going to party at the
Are you kidding me?
Come on, man.
Chapter. Schedule.
Throw 'em back. Saturdays are for the boys.
My sister's got a Padre. I'm just working.
That sounds so
I have
much fun.
coworkers going to Padre too.
I'm literally, as of like last week on Wednesday, I'm working 20 days in a row.
That has been changed.
Don't do that to yourself.
Well,
Hey, Sam's
spring
gonna be
break,
nice.
I asked for the 2 days that I have off to be scheduled. And then he took somebody off the schedule because he tried to like always ask for hours and then refused the hours that he was giving. He was like, I'm taking you off the schedule. He took him off the schedule for like 2.5 weeks.
Oh, wow. Well, I guess that's what you get when you get that.